Good morning. I am D. Sengodin, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today our topic is crystal physics. So we are going to study about introduction of crystal physics, crystalline, non-crystalline materials, space lattice, crystal structure, lattice parameters, crystal systems, and Bravais lattices. So the first topic is introduction to crystal physics. So in this matter, in this world fully filled with the gases, liquids and liquids or crystals, solids. Then the next question is, so what is crystal physics? Physical properties of crystalline solids, determination of the reaction structure by using X-rays, neutron beams and electron beams. Then the crystalline solids have arrangement of atoms or molecules in a regular and periodic manner. Then they have anisotropic substance, sharp melting point, then possess a regular shape. Then example for crystalline solids: iron, copper, carbon, and germanium. Then the non-crystalline or amorphous materials have irregular arrangement of atoms or molecules. The particles are randomly distributed. Then they are isotropic substance. Then they have wide range of melting point. Then examples for non-crystalline: glass, plastics, and rubber. So the next topic is polycrystalline solids. Many small single crystals, high degree of order over many atomic and molecular dimensions, grain boundaries. Then grain sizes are usually 100 nanometer to 100 microns in diameter. And the polycrystals with grains less than 10 nanometer in diameter of nanocrystalline. Then the important crystallographic terms: space lattice, lattice points, lattice line, lattice planes, basis, crystal structure, unit cell, and lattice parameters. So the first topic is space lattice, regular and periodic arrangement of atoms of points in 3 dimensions. So that particular point indicates the position of atoms or molecules. So in base is unit assembly of atoms or molecules which are identified with respect to the position of lattice point. So that next the diagram shows that the lattice point plus base is equal to crystal structure. So the lattice point denoted as a position of atoms or molecule, that is imaginary point. Then the lattice point plus base is atoms or molecules equal to crystal structure. Then the next title is unit cell, the fundamental building block. So repeating its own dimensions in various directions gives crystal structure. So then next, the important lattice parameters in a crystal: the x, y, z are crystallographic axis. Length of the unit cell along the x, y, z direction are a, b, c. The angle in between a and b equal to alpha, b and c equal to beta, and then the c and a equal to gamma. So ABC is known as axial length of crystal structure, and then alpha, beta, gamma equal to interaxial angle. So then the next title is primitive and non-primitive cell. If the lattice points at corner only, that is called primitive cell. In case more than one corner point, that is called non-primitive cell. Then the example for primitive, that is simple cubic. So simple cubic normally have lattice points at corner only. So example for non-primitive cell: pod center cubic, face center cubic, and base center cubic. Non-primitive cell, if a unit cell consists of more than one lattice point or one atom, that is called non-primitive cell. So finally, this diagram shows that 7 important crystal systems. First system's title is cubic, then rhombohedral, tetragonal, hexagonal, monoclinic, orthorhombic, and triclinic. Based on the axial length and axial angle, systems are 7 types. So finally, there are 7 systems are available. So for example, in cubic system, the axial length a equal to b equal to c. Then the axial angle alpha, beta, gamma equal to 90 degree. Then this rhombohedral system a equal to b equal to c. Then interaction angle in between A equal to beta, alpha equal to beta equal to comma equal to not equal to 90 degree. In the tetragonal hexagonal system, there are different types of angle and axial length. So these all are the 7 systems are available in the crystalline materials. Thank you.